da 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 dun dun da dun da 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 da. Greetings, this is Bradford Donald Keller Townsend, and this is a forward research report. And today is a primer on petroleum, the lifeblood of mechanical civilization. I will read first from the Encyclopedia Britannica under the listing Petroleum, written by Priscilla G. McElroy, Gordon I. Atwater, Joseph P. Riva. Petroleum, the complex mixture of hydrocarbons that occur in earth in liquid, gaseous, or solid form. The term is often restricted to the liquid form, commonly called crude oil, but as a technical term, petroleum also includes natural gas and the viscous or solid form known as bitumen, which is found in tar sands. The liquid and gaseous phases of petroleum constitute the most important of the primary fossil fuels. Liquid and gaseous hydrocarbons are so intimately associated in nature that it has become customary to shorten the expression petroleum and natural gas to petroleum when referring to both. The word literally rock oil, from the Latin petra, rock or stone, and oleum, oil, was first used in 1556 in a treatise published by the German mineralogist Georg Bauer, known as Georgius Agricola. The burning of fossil fuels and coal and biomass included releases large quantities of carbon dioxide, CO2, into the atmosphere. The CO2 molecules do not allow much of the long-wave solar radiation absorbed by the Earth's surface to re-radiate from the surface and escape into outer space. The CO2 absorbs upward propagating infrared radiation and reemits a portion of it downward, causing the lower atmosphere to remain warmer than it would otherwise be. This phenomenon has the effect of enhancing Earth's natural greenhouse effect, producing what scientists refer to as anthropogenic, human-generated global warming. There is substantial evidence that higher concentrations of CO2 and other greenhouse gases have contributed greatly to the increase of the Earth's near-surface mean temperature since the year 1950. History of seeps. Small surface occurrences of petroleum in the form of natural gas and oil seeps have been known from early times. The ancient Babylonians used crude oil, bitumen, pitch, collected from large seeps more than 5,000 years ago. Liquid oil was first used as a medicine by the ancient Egyptians. The Assyrians used bitumen as a means of law breakers. Oil products of war in the ancient world. The Persians arrows wrapped in oil-soaked fibers at the siege of Athens in 480 before the Common Era. Early Arabs and Persians distilled crude oil to obtain flammable purposes. Probably as a result of the Arab invasion of Spain, the industrial art of distillation into illuminants became available in Western Europe by the 12th century. Several centuries later, Spanish explorers discovered oil seeps in the present-day Cuba, Mexico, Bolivia, and Peru. Oil seeps were plentiful in America and were also noted by early explorers in what are now New York and Pennsylvania, where American Indians were reported to have used the oil for medical purposes. Extraction from underground reservoirs. Until the beginning of the 19th century, illumination in the United States and other countries was little improved over that which was known during the times of the Mesopotamians, Greeks, and Romans. Greek and Roman lamps and light sources often relied on oils produced by animals such as fish, birds, and plants, such as olive oil, sesame, and nuts. Timber was also ignited to produce illumination. Since timber was scarce, limestone was infused with bitumen and fibers for the use development of urban centers. History of use. Exploration of surface seeps. Small surface occurrences of petroleum in the form of natural gas and oil seeps have been known from early times. The ancient Sumerians, Assyrians, and Babylonians used crude oil, bitumen, and asphalt pitch collected from large seeps at Tutalhu, modern-day Hit, on the Euphrates, for many purposes more than 5,000 years ago. Liquid oil was first used as a medicine by the ancient Egyptians, presumably as wound dressing, liniment, and laxative. The Assyrians used bitumens as a means of punishment by pouring it over the heads of lawbreakers. Oil products were valued as weapons of war in the ancient world. The Persians used incendiary arrows wrapped in oil-soaked fibers at the siege of Athens in 480 before the Common Era. Early in the Common Era, the Arabs and Persians distilled crude oil to obtain flammable products for military purposes, probably as a result of the Arab invasion of Spain. The industrial art of distillation into illuminants became available in Western Europe by the 12th century. Several centuries later, explorers discovered oil seeps in present-day Cuba, Mexico, Bolivia, and Peru. Oil seeps were plentiful in North America, were also noted by early explorers in what are now New York and Pennsylvania, where American Indians were reported to have used the oil for medical purposes. Extraction from underground reservoirs. Until the beginning of the 19th century, illumination in the United States and in many other countries was little improved over that which was known during the times of Mesopotamians, Greeks, and Romans. Greek and Roman lamps and light sources often relied on oils produced by animals such as fish and birds and plants such as olive, sesame, and nuts. Timber was also ignited to produce illumination. Since timber was scarce in Mesopotamia, rock, asphalt, sandstone, or limestone infused with a bitumen or petroleum residue was mined and combined with sand and fibers for use in supplementing building materials. The need for better illumination that accompanied the increasing development of urban centers made it necessary to search for new sources of oil, especially since whales, which had long provided fuel for lamps, were becoming harder and harder to find. By the 19th century, kerosene, or coal oil derived from coal, was in common use in both North America and Europe. The Industrial Revolution brought an ever-growing demand for a cheaper and more convenient source of lubricants, as well as illuminating oil. It has also required better sources of energy. Energy had previously been provided by human and animal muscle, and later by combustion of such solid fuels as wood, peat, and coal. These were collected with considerable effort and laboriously transported to the site where the energy source was needed. Liquid petroleum, on the other hand, was a more easily transported source of energy. Oil was a much more concentrated and more flexible form of fuel than anything previously available. The stage was set for the first well specifically drilled for oil, a project undertaken by American entrepreneur Edwin L. Drake in northwestern Pennsylvania. The completion of the well in August 1859 established the groundwork for the petroleum industry and ushered in the closely associated modern industrial age. Within a short time, inexpensive oil from underground reservoirs was being processed at already existing coal oil refineries, and by the end of the century, oil fields had been discovered in 14 states, from New York to California, and from Wyoming to Texas. During the same period, oil fields were found in Europe and in East Asia as well. Significance of petroleum in modern times. At the beginning of the 20th century, the Industrial Revolution had progressed to the extent that the use of refined oil for illuminants ceased to be of primary importance. The oil and gas industry became the major supplier of energy, largely because of the advent of the internal combustion engine, especially those in automobiles. Although oil constitutes a major petrochemical feedstock, its primary importance is as an energy source on which the world economy depends. I'll read that again. Although oil constitutes a major petrochemical feedstock, its primary importance is as an energy source on which the world economy depends. Depends. The significance of oil as a world energy source is difficult to over-dramatize. The growth in energy production during the 20th century was unprecedented, and increasingly oil production has been by far the major contributor to that growth. By the 21st century, an immense and intricate value chain was moving approximately 100 million barrels of oil per day from producers to consumers. The production and consumption of oil is of vital importance to international relations and has frequently been a decisive factor in the determination of foreign policy. The position of a country in this system depends on its production capacity as related to its consumption. The possession of oil deposits is sometimes the determining factor between a rich and a poor country. for any country, the presence or absence of oil has major economic consequences. On a timescale within the span of prospective human history, the utilization of oil as a major source of energy will be a transitory affair lasting only a few centuries. Nonetheless, it will have been an affair of profound importance in a world industrialization. Properties of hydrocarbons, chemical composition, hydrocarbon content. Although oil consists basically of compounds of only two elements, carbon and hydrogen, these elements form a large variety of complex molecular structures, regardless of physical or chemical variations. However, almost all crude oil ranges from 82 to 87% carbon by weight and 12 to 15% hydrogen. And the more viscous bitumens generally vary from 80 to 85% carbon and from 8 to 11% hydrogen. Crude oil is an organic compound divided primarily into alkenes with a single bond hydrocarbons of the form CnH2n plus 2 or aromatics having 6-ring carbon hydrogen bonds, carbon 6, hydrogen 6. Most crude oils are grouped into mixtures of various and seemingly endless proportions. No two crude oils from different sources are completely identical. The alkane paraffinic series of hydrocarbons, also called methane carbon hydrogen 4 series, comprises the most common hydrocarbons in crude oil. The major constituents of gasoline are the paraffins that are liquid at normal temperatures but boil between 40 degrees Celsius and 200 degrees Celsius or 100 degrees Fahrenheit and 400 degrees Fahrenheit. The residues obtained by refining low-density paraffins are both plastic and solid paraffin waxes. The Naphthenic Series has the general form C subscript N, H subscript 2N, and is saturated closed ring series. This series is an important part of all liquid refinery products, but it also forms most of the complex residues from the higher boiling point ranges. For this reason, the series is generally heavier. The residue of the refining process is an asphalt, and the crude oils in which this series predominates are called asphalt-based crudes. The aromatic series is an unsaturated closed-ring series. Its most common member, benzene, carbon subscript 6, H subscript 6, 6 carbons, 6 hydrogens, is present in all crude oils, but the aromatics as a series generally constitute only a small percentage of most crudes. Non-hydrocarbon content. In addition to practically infinite mixtures of hydrocarbon compounds that form crude oil, sulfur, nitrogen, and oxygen are usually present in small but often important quantities. Sulfur is the third most abundant atomic constituent of crude oil. It is present in the medium and heavy fractions of crude oil. In low and medium molecular ranges, sulfur is associated only with carbon and hydrogen, while in heavier fractions it is frequently incorporated in the large polycyclic molecules that also contain hydrogen and oxygen. The total sulfur in crude oil varies from below 0.05% by weight, as in some Venezuelan oils, to about 2% for average Middle Eastern crudes, and up to 5% or more in heavy Mexican or Mississippi oils. Generally, the higher the specific gravity of crude oil, which determines whether the crude is heavy, medium, or light, the greater its sulfur content. The excess sulfur is removed from crude oil prior to refining because sulfur oxides released into the atmosphere during the combustion of oil would constitute a major pollutant, and they also act as a significant corrosion agent in and on oil processing equipment. The oxygen content of crude oil is usually less than 2% by weight and is present as part of the heavier hydrocarbon compounds in most cases. For this reason, the heavier oils contain the most oxygen. Nitrogen is present in almost all crude oils, usually in quantities of less than 0.01% by weight. Sodium chloride also occurs in most crudes and is usually removed like sulfur. Many metallic elements are found in crude oils, including most of those that occur in seawater. This is probably due to the close association between seawater and the organic forms from which oil is generated. Among the most common metallic elements in oil are vanadium and nickel, which apparently occur in organic combinations as they do in living plants and animals. Crude oil also may contain a small amount of decay-resistant or organic remains, such as siliceous skeletal fragments, wood, spores, resins, coal, and various other remnants of former life. Physical properties. Crude oil consists of a closely related series of complex hydrocarbon compounds that range from gasoline to heavy solids. The various mixtures that constitute crude oil can be separated by distillation under increasing temperatures into such components as, from light to heavy, gasoline, kerosene, gas oil, lubricating oil, residual fuel oil, bitumen, and paraffin. Crude oils vary greatly in their chemical composition because they consist of mixtures of thousands of hydrocarbon compounds, and their physical properties such as specific gravity, color, and viscosity. Resistance of a fluid to a change in shape also vary widely. Specific gravity. Crude oil is immiscible with and lighter than water, hence it floats. Crude oils are generally classified as bitumens, heavy oils, and medium and light oils on the basis of specific gravity, i.e., the ratio of the weight of equal volumes of oil and pure water at standard conditions, with pure water considered to equal 1, and relative mobility. Bitumen is an immobile, degraded remnant of ancient petroleum. It is present in oil sands and does not flow into a well bore. Heavy crude oils have enough mobility that, given time, they can be obtained through a well bore in response to enhanced recovery methods. That is, techniques that involve heat, gas, or chemicals that lower the viscosity of petroleum to drive it toward the production well bore. The more mobile, medium, and light oils are recoverable through production wells. The widely used American Petroleum Institute, acronym API, API gravity scale is based on pure water, with an arbitrarily assigned American Petroleum Institute gravity of 10 degrees. American Petroleum Institute gravities are unitless and are often referred to in degrees. They are calculated by multiplying the inverse of the specific gravity of a liquid at 15.5 degrees Celsius or 60 degrees Fahrenheit by 141.5. Liquids lighter than water, such as oils, have API gravities numerically greater than 10 degrees. Crude oils below 23.3 degrees API gravity are usually considered heavy, whereas conventional crudes with API gravities between 22.3 degrees and 31.1 degrees are regarded as medium, and light oils have an API gravity of 31.1. Optimum refinery crude oils considered the best are 40 degrees to 45 degrees, since anything lighter is composed of lower carbon numbers, the number of carbon atoms per molecule of material. Refinery crudes heavier than 35 degrees API have higher carbon numbers and more complicated to break down or process for optimal octane gasolines and diesel fuels. Early 21st century production trends showed, however, a shift in emphasis toward heavier crudes as conventional oil reserves, that is, those not produced from source rock, declined and a great volume of heavier oils was developed. Boiling and freezing points. Because oil is always at a temperature above the boiling point of some of its compounds, the more volatile constituents constantly escape into the atmosphere unless confined. It is impossible to refer to a common boiling point for crude oil because the widely different boiling points of its numerous compounds, some of which may boil at temperatures too high to be measured. By the same token, it is impossible to refer to a common freezing point for crude oil, because the individual compounds solidify at different temperatures. However, the pure point, the temperature below which crude oil becomes plastic and will not flow, is important to recovery and transport, and is always determined. Pure points range from 32 degrees Celsius to below negative 57 degrees Celsius, 90 degrees Fahrenheit to below 70 degrees Fahrenheit. Measurement systems. In the United States, crude oil is measured in barrels of 42 gallons each. The weight per barrel of API 30-degree light oil is about 306 pounds. In many other countries, crude oil is measured in metric tons, for crude oil having the same gravity. A metric ton is equal to approximately 252 imperial gallons, or about 7.2 United States barrels. Origin of hydrocarbons. Formation process. From planktonic remains to kerogen, the immature stage. Although it is recognized that the original source of carbon and hydrogen was in the materials that make up primordial Earth, it is generally accepted that those two elements had to pass through an organic phase to be combined into the varied complex molecules recognized as hydrocarbons. The organic material that is the source material of most hydrocarbons was probably been derived from single-celled planktonic, free-floating plants such as diatoms, and blue-green algae. And single-celled planktonic animals such as foraminifera, which live in aquatic environments of marine, brackish, or fresh water. Such simple organisms are known to have been abundant long before the Paleozoic era, which began some 541 million years ago. Rapid burial of the remains of the single planktonic animals within 5-grain sediments effectively preserved them. This provided the organic materials and so-called proto-petroleum. For later Diagenesis, a series of processes involving biological, chemical, and physical changes into petroleum. The first or immature stage of hydrocarbon formation is dominated by biological activity and chemical rearrangement, which convert organic matter to kerogen. This dark-colored, insoluble product of bacterially altered plant and animal detritus is the source of most hydrocarbons generated in the later stages. During the first stage, biogenic methane is the only hydrocarbon generated in common quantities. The production of biogenic methane gas is part of the process of decomposition of organic matter carried out by anaerobic microorganisms, those capable of living in the absence of oxygen. The power of petroleum, which is bitumens, natural gas, liquid oil, some of which is quite different from each other, is not to be underestimated. It cannot be overhyped. It is literally in you, or you are made up of oil. Fertilizers, and even if you've gone organic lately, you probably don't eat organic all the time, and fertilizers that come from methane and petroleum oil are, you eat that food, a slice of pizza, and some of it is from fertilizer in the wheat of the flour, in the tomato sauce, in the olives or whatever toppings you have. And it would be in the meat, as the animals are definitely going to be fed in most cases soy, bean, meal, or grains that generally they are not fed organic food. So you're getting fertilizer that, indirectly through animal flesh. It is super important to understanding geopolitics, the wealth of nations, why we go to war over oil. When you realize over 600,000 plus products have oil embodied in them, that it is used as a fertilizer, it is used to produce over 90% of the food through fertilizers, pesticides, herbicides, fungicides. It is used as the diesel fuel to power the machinery. It is used for diesel fuel to transport the seeds and all the materials needed to agriculture, to get it back over roads that are covered with asphalt, built with ingredients of fossil fuels, powered by fossil fuel internal combustion engine machines. It's been quite a long audio video. This would be good to listen to on a train, a plane, in bed maybe. I hope some young people take advantage of this. Maybe if you don't speak English as your first language, my pronunciation, as I have lived in New York City, the Bahamas, Jacksonville, Florida, San Diego, California, Chicago, Illinois, Livorno, Italy, and I have lived in Indianapolis, Indiana. So Lexington, Virginia. So having spent more than a few weeks in each of those, where I pick up some of the accent, the British accent from the Bahamas, and having family members that have lived in England and spent time with the British community here in Indianapolis. And we do have one of when I was growing up of recent immigrants who were born in the British Isles. Um, Thank you very much. I hope you benefited from this information. I hope it stimulates further investigations, and it will make you a wiser, more knowledgeable human being. Thanks, and have a wonderful day.